Concrete is a mixture of coarse and fine aggregates with a base of binder material and water. When cement is mixed with a small amount of water, it hydrates to form microscopic opaque crystal lattices, encapsulating and locking the aggregate into a rigid structure. Typical concrete mixes have high resistance to compressive stresses. However, any appreciable tension due to bending will result in cracking and separation of the concrete. Due to concrete being weak in tension, it needs to be reinforced so that it will not only resist compression but also bending and other direct tensile actions. Reinforced concrete can build many types of structures and components of structures, including slabs, walls, beams, columns, foundations, frames, and more. Reinforced concrete can be classified as precast or cast in place. In today's episode, we are going to discuss about two concrete structures. The first is Lagarian Bridge linking Scout Tobias and Doña Hemadi in Quezon City, Philippines. The second is the drainage system at Blumentritt. The construction and rehabilitation of drainage systems are also known as the Blumentritt Interceptor Catchment Area. In line with this, we hope to discuss the basic principles used in the construction of the said structures and the parts of each structure. We hope to answer the following. What are the parts of each structure? How are they made? And why are they made? Welcome to the wonderful world of reinforced concrete design.
More bridges are built using concrete. It can be said that it is the material of choice worldwide. This demonstrates continued confidence in the material's performance and durability. Concrete bridges worldwide have a clear track record of flexibility and versatility in terms of final forms and methods of construction that is hard to match. Durability, aesthetics, economic solutions, simplified construction, and rapid deployment techniques all contribute to making concrete the best construction material for any bridge project, whatever the size, form, or intended use. Greater construction flexibility can be realized through the many forms of concrete easily available, making concrete an adaptable resource suitable for deployment for even the most challenging bridge types. One example of concrete bridge is the Lagarian Bridge that will span Cal Tobias and Doña Gema districts. This bridge is to become a convenient shortcut from New Manila area going to Roses Avenue, Timog Avenue, or Quezon Avenue. This bridge is a project of DPWH. The project was awarded to Mr. A.C. Maharas as its contractor. The project is still ongoing and its budget cost is approximately 48 million pesos. Let us first discuss the main parts of a bridge to have a better understanding. A bridge has three main elements. The first element is the substructure or foundation. It transfers the loaded weight of the bridge to the ground. It consists of components such as columns, also called as piers and abutments. The second element is the superstructure of the bridge. It is the horizontal platform that spans the space between columns. Finally, the last element is the deck of the bridge. It is the traffic carrying surface added to the superstructure.
The place was surveyed for the purpose of excavation and hauling. For the foundation of the Lagarian Bridge, longboard piles were used to resist the expected loads of the structure. The next step is creating the pile cap, that is a thick concrete mat that distributes the loads into the piles. The pile cap includes a shear block that keeps the girders in place and resisting lateral forces like earthquake and wind loads. Another part of the bridge is the wing wall that are constructed adjacent to the abutments and act as retaining walls. The soil and fill supporting the roadway and approach embankment are retained by the wing walls. For the superstructure of the bridge, 5 spans of steel I-beams and 5 concrete girders were used. The long steel I-beams that spans along the bridge are welded in top of 2 horizontally placed I-beams that are also welded beneath the pile cap. Steel plate molds and coco lumber are used as formworks and supports for the construction of the girders. After the pouring of concrete, it was cured by sprinkling water regularly. The girders are pre-stressed using a set of tendons that are fished through the dock. They are tensioned using jacks that react or push against the concrete member itself. Initial stressing is done when the cement reaches 1000 psi and final stressing when it reaches 80% of 5000 psi. The tendons lengthen by 5 centimeters in the initial stressing and 15 centimeters in the final stressing. The final part of the project is the construction of the bridge deck, which is the roadway itself, including the pedestrian walkway. The total span of the bridge is 75 meters. In the span above the creek, is only 25 meters. The bridge has a width of 10.4 meters and a depth of 3.3 meters with respect to the pipe cup. The girder has 3 diaphragms and are located at the middle and both ends. Diaphragm is a member that resists lateral forces and transfers loads to supports. It is needed for lateral stability during erection and for resisting and transferring earthquake loads. Up next, the discussion about the catchment area. Stay tuned, only here on PORMMWorks, making engineering life better.
Wait, ano ba to? Choco na gatas o gatas na choco?
Choco na gatas.
Gatas na choco.
Choco na gatas.
Gatas na choco.
Choco na gatas.
Gatas na choco.
Choco na gatas.
Gatas na choco nga eh.
Choco na gatas. Wala mong panlasa.
Gatas na choco, lasang-lasa ko nga eh.
Nag-awayan niyo. Champurado to. Ang gatas sa choco. Ang choco na gatas.
Bear brand, confusing people in the day it was made.
Sawa ka na ba sa iyong kutis Pilipino? Kutis Chinita ang mas trip mo? Pues, Kochikso ang sagot sa problema mo. How does it feel?
Philippines. Copico, your coffee specialist, presents Copico Astig 3-in-1. Stronger and richer coffee come from grade 1 selected coffee bean. Full and properly roasted. Be 100% Astig. Wow! I feel good. Knew that I would not. I feel good. I knew that I would not. Stay 100% awake with Copico Astig 3-in-1. Copico Astig 3-in-1. Astig na kape.
Flooding due to stormwater is not a new problem in the Philippines. It is caused not only by typhoons, but also of urbanization. Most cities in the Philippines have combined sewer systems, which means that there are no separate stormwater and wastewater sewer systems. Wastewater from septic tanks freely mixes with stormwater. In practice, this is not as bad as it sounds, as the volume of stormwater is large and may well flush out the drainage system and its contents into the streams and rivers. The installation and maintenance of drainage systems is one of the major responsibilities of local government. One of the projects of the government is the construction and the rehabilitation of the drainage system Blumentritt Interceptor Catchment Area,
The project aims to store and divert stormwaters coming from Quezon City to Manila at Blumentritt Street. Once diverted, the water will travel from Blumentritt to Espana, to Dapitan, to Laong Laan, then to Chinese General Hospital, then to Aurora, and finally to Hermosa Street. The project has two roles. One is the diversion of water, and two is the storage of water. The water that will come to Hermosa Street will then be pumped at Estero de Sunog Apog. The project currently being constructed was awarded to Northern Builders, a contractor with a AAA rating. With the construction approaching its finish, Metro Manilans may get some relief with a 3.3 kilometer long catchment area designed to store floodwaters that could fill 14 Olympic-sized swimming pools. The drainage facility used reinforced concrete box culvert as its basic design.
To create an effective catchment area, certain steps need to be followed. These are the steps in construction of the culvert interceptor system at Blumentritt. The first of which is surveying. Surveying is integral in the construction process because it gives the engineer an overview of the flow construction site. It also gives way to strategic planning. In each of the 4 phases of the project, a surveyor and 3 survey aides are assigned. The area is then surveyed for preparation of holing and construction of the box culverts. The second step is sheet piling. Sheet piles will be driven to prevent landslides and soil failures. When the sheet piles have been driven, the area becomes ready for excavation. The area is then excavated and the excavated particles are then holed. The next step is the preparation for lean concrete. The lean concrete is where the box culvert will be erected. 4,000 psi concrete is used in pouring this structure. After the lean concrete is cured, the installation of rebars for the bottom slab and part of the wall structure is then installed. Formworks are then installed, aiding in shaping the concrete structure. Every time installation of rebars is finished, it is to be inspected by the DPWH. Once approved, pouring of concrete is carried out. Again, once the concrete for bottom slab is cured, the same process is repeated for the wall structure, top slab structure, and the Portland cement concrete pavement. Installation of rebars, installation of formworks, inspection, pouring, curing for 14 days, inspection. After creating the reinforced concrete box culvert, preparation for the concrete pavement is prepared. They will also provide formworks for the concrete pavement and then pour the Portland cement concrete pavement. The process is done by parts until it finishes the 3.3 kilometer interceptor.
We are having a break. Stay tuned.
Sleeping on the job? Letting your thesis mates down? Worry no more, for there is Extra Jaws!
Just add 200 milliliter of water and you are already ready to go.
Para lang yun. Sa manalo naman yun.
Uy guys! Merienda muna!
Wow, si Shelma! Sana ipapakain. Kuya, ito!
Hindi.
Bakit? Ano ba ito ah?
PORMMWorks pizza. Definitely made for sharing.
Did you know that there are 3 types of box culverts that can be found throughout the project? These are 2.4 by 2.4 square meters RCBC, 2.4 by 2.75 square meters RCBC, and 3 by 3 square meters RCBC. The thickness of walls and slabs is 0.3 meters. The total length of the project is 3.3 kilometers. Grade 60 and grade 40 steel are used in the construction of the project. There are 9 types of bar bending in each of the faces. A manhole can be found in every 5 linear meters of the project. Concrete spacers are also used in the construction.
So, that comprises our report. We hope this increased your knowledge about bridges, catchment area, and most especially, concrete. Again, we are PORMMWorks.
Ka nang umiyak sa mundong pabago-bago.